Welcome, everyone. Thank you for joining us today. My name is Chris Baker, and I'm joined by Sam Sesti, the president and founder of ONU, and we're really excited to have you with us. Today, we're going to introduce you to our brand new Convert and Optimize product from ONU on the OnShape store. And before we get into the details, Sam's going to run a demo eventually. I'd like to run you through a little bit of background on the ONU team and the company, what we've been doing over the past few years, and then we'll dive right into the details. So ONU, fundamentally, we're pioneers in next-gen visualization technology, create 3D assets, and we empower organizations to use those in novel ways. We were founded in 2014, almost exactly 3 years ago, and we're based in Royal Oak, Michigan. And our team here has extensive experience in 3D graphics, software development, asset creation for a variety of purposes, and associated activities. And we've worked very closely with companies in a few industries over the past few years, including automotive, footwear, athletic equipment, and other consumer products. And that breadth of industry coverage is growing by the day. So when we talk about ONU, what we bring to the table is really unique and pretty exciting. And as you learn more, you'll see how that works. So we are the only cloud-based end-to-end solution for asset creation from CAD. And for the OnShape user community that's dealing with CAD day in, day out, this is a pretty exciting technology. We use patent pending, a foundation that's patent pending to drive this. And we leverage that existing CAD that you have on hand that's often shelved after the initial design process, and we take that to the marketing departments and elsewhere within your organizations to realize its full value. In doing so, we're creating real-time rendered photorealistic visuals, and we're outputting in generic formats. So I should step back and say that to begin with, we're CAD agnostic. So while you can use OnShape as your baseline, you can use any input for our products, for our platform. And on the back end, when we output data, we're also using a generic format like FBX and OBJ. So we like to consider ourselves process compatible across the board. In the end, users can also, with our cloud platform, can also manage all of their assets on an ongoing basis, considering version control and other things along those lines. In terms of the way we work, well, it's pretty straightforward. You upload your CAD file to our cloud platform, and then we push it through using that patent pending technology again in a step that we call our Convert and Optimize product. And we'll really be getting into the details of what that involves in a few minutes. After we export an FBX or OBJ file from that Convert and Optimize step, then we can dress it up for visuals and eventually publish it to a variety of endpoints, using that single asset to serve a variety of purposes in your organization. They could be AR, it could be VR, it could be web, it could be mobile. But the nice thing here is that you're using one process to create an asset that will serve all of those purposes rather than doing redundant work. Speaking about the app itself, the app is focused on Convert and Optimize, that step that takes your CAD and creates a lightweight polygonal file that can then be viewed and served as the basis for meeting those various endpoint requirements. So we automatically convert and optimize that CAD file into a polygonal file, and you can see here one example where we've imported this gear set and eventually reduced it to only 30,000 polys while still retaining a reasonable level of detail. And that's really the crux of it. How do you optimize a model like this and still retain enough detail? And in doing so, part of this process, part of the unique capability that we offer is the retention of all of the part naming and hierarchy. So all of that is available, as you'll see in a few minutes. And again, once you have these lightweight assets, you can manage them on our platform and make them readily available to anybody in your organization easily. The platform's powered by Amazon Web Services, so the uptime's second to none, and the reliability is right there. So in terms of popular uses, we've worked closely with a number of customers in the industries I mentioned a few minutes ago. Visual and interactive tech manuals, we've seen some uptake there where customers are realizing that their companies, their customers learn better when they see things visually and interact with those visuals. So we're able to power more interactive, immersive experiences in that fashion. Same goes for product tutorials. And when you talk about product tutorials, you can look at websites, you can talk about customizers for B2B and B2C platforms using our class-leading WebGL technology, and really that fundamentally creates a much more immersive experience. And then in the end, the efficiency that we deliver with this technology, generating assets in only minutes, really lends itself to large-scale asset creation. Companies that have thousands upon thousands of products in their catalogs, and they need to make all of those into 3D visuals, well, we can do that in a very efficient, streamlined way. So on that note, let me hand it off to Sam, and let's show you what the app is all about.
Thanks, Chris. As Chris mentioned, we've recently released into the OnShape store, and we're excited about that. So I'm going to lead you through what that app looks like and show you a little about it. So first thing you guys may be familiar with is the OnShape store here, which I have pulled up. I'm just going to search for our app. There we are. Convert and optimize. And you can see a little bit about it. It's a free app with, you can use it for all the functions available. We do limit you to 3 exports currently, and I'll get into the export process a little later. But we go through here and talk about the different features and value that we provide that we'll go through in our demonstration. So this one's already installed, so I won't bother to do that. What I will do is then show you how it works over on the OnShape side. So this will be familiar for everybody, showing all of my different assemblies, different OnShape documents. What I'm going to do is grab one of these here and pop into that. And as you'll see in a second, this is going to be internal for a company we worked with that has a charging technology for for cell phones, etc. And you can see, the model we have here, the assembly. I'm going to move it around a little bit so everybody can get an idea of what it's made up of. It's got a plug there to plug in the wall. It's got some battery, some inputs for USB and charging, etc. So what I'm going to do is I'm going to then show how that can be brought into our application. So everyone might be familiar with how to add an application here. I'm going to go here and add this. What that's going to do is open up an instance of our application right here embedded in a tab within the document. It's going to give me the opportunity to pick between the full assembly or different pieces of the assembly. I'm just going to choose the full assembly, and from there I get some options. Basically, these are kind of canned at the top with small, medium, and large. But I have some options below I can go through. One is a deviation angle, something that might be a little more familiar to engineers or someone familiar with 3D modeling. And it's going to, something about it's going to create larger file sizes, giving you a higher resolution based on your deviation angle. And we can take this up and down to give us less detail or more detail within our resulting model. And then auto size as well, about how it affects the size of the end product. And again, we can move this down for more detail or less detail. what I'm going to do is just pick as a small item, something around the size of a, coffee cup or in that range, and let it go with its automatic settings from there. And what I'll do there is I'm going to hit upload, and that's going to go through our pipeline here. Since it's already uploaded and we know it's an OnShape document, we can skip right to converting. And what this is doing is converting it to a step file. So we start with that ubiquitous format that everybody's probably fairly familiar with on the engineering side. And once it's done converting to that format, then it'll go into the optimizing step. And what we're doing there is what Chris was explaining before. We're finding that balance between visual quality and density. So as you can imagine, CAD files rich with data become dense when they're converted to mesh or polygonal format, which again, that format is necessary for most real-time rendering engines that are used today, whether it be OpenGL, WebGL, augmented or virtual reality with Unreal Engine or ARKit or Unity or whatever those might be. So optimizing that polygonal model to something that plays well and can perform at 60 or 90 or 120 frames per second or whatever is going to be needed in the experience you're targeting is really important. So and the reason that's important is because if you start with something very dense, so if you go into any of your normal software, like if you take this CAD file into 3ds Max or something like that, what you'll end up with is kind of a one-to-one size transfer. So you'll end up with the same amount of density just in mesh or polygonal form. And at that point, the way to reduce polygons or to reduce density, your options are limited. Really, you're looking at, in general, some primitive polygon reducing or decimation algorithms, or in most cases people are using those as a guide and then remodeling from scratch in lower poly. So what we're looking to do is be more cost effective and more time efficient when making that conversion. So now it's going to the optimizing step, and I can show you what that's going to look like when it's done. So we're going to pop over here, kind of have this done just like they do on the cooking shows, and show you what it looks like when it's complete. So when it's complete, I get this polygonal model that's here in my viewer, and I can move this around. This is still real-time rendering. I'm able to zoom in, zoom out, move it around. I'm going to save the position to something that's a little better for me to look at from the start. But so what I have here then is this visual that is now optimized. So if I look at the bottom, I've got a 22,000 poly count, which is well within the parameters of playing on any of those real-time endpoints we discussed. In fact, I think that we could go quite a bit higher and still play in any of those formats. So what I could do, for example, is take this up and add some detail, and you can see at the bottom I went up about 8,000 polygons, so to 30,000 total. Right now we create 3 levels of detail automatically. You can see if I go left, I lose a few thousand polygons and get down to 19,000. And as I'm doing this, you may or may not be able to see in the visual, it's re-rendering real time, so I can see what the difference is going to be. You probably can't see anything from your perspective. It's kind of hard to see from the naked eye right now because there isn't much difference, which is a good thing. Really, if you could tell a lot of difference, you might be causing some issues with the end product. But as it stands, we're able to kind of go with whichever of these we want. We can then save it if we'd like, and then we're kind of playing at that level of detail. So I can save that one. And that'll be our current level of detail that we're working with when we share it or export it out. And again, we save 3 levels of detail by default, just an arbitrary number we've chosen. So beyond being able to visualize this, we have the ability to share it. So I can come here and copy and share a link, and if I go over into a new browser window here, everybody will be able to see that this shows up just like I was looking at in my OnShape document. And so this could be shared for a number of purposes. I could email this out or text this out to somebody, email it to a client, so you could do a design type review in a kind of a, I'll call it a sterile setting, such that they're not seeing a lot of the OnShape details that you might not want them to see, or just get some feedback, or just sanity check from someone, or just share your design, something cool that you created that you wanted to share with someone. But again, this link that you're sending out is a read-only, obviously view-only link that really allows you to just, you know, give somebody an idea of what you're looking at. And at this point, you could even share it with like a marketing group, for example, and say, hey, you know, what do you guys think of this design? This is kind of this is the track we're on, or sales, or whomever your peers are within your organization that might have some input as to your product. A couple buttons down here. One is for full screening it. The other one's for help. You can kind of see how to move it around. So if people are unfamiliar with how to move a model around in space, since they're not a designer, you can get some help from that button. I'm going to show you what we can do to export. So again, exporting an FBX here, and if you aren't familiar with the FBX format, it's a kind of a common 3D modeling format that's considered somewhat agnostic, if you will, like Chris was talking about, and that will allow us to get this out into our, and then we can share that out, and that can be then used to be sent to a marketing person or salesperson or someone that's going to be then responsible for engaging with maybe an agency that might want to make this look and feel kind of you know, nicer and more photorealistic. They may get readying it for VR, AR, something like that. So to show you an example of some of what can be done with that, I'm going to pop you over here to one of our demonstration sites so I can show you kind of this product. I think this is the outside of the charger that we were showing you, and here you can see how photorealistic this has been made. You can see it has real life materials. I'm zooming in on it now. I can zoom back out. You can add animations through 3D modeling, which can be shown in this case in a web browser. You can show how the connectors come out of the product, or you can show the interior, which is the part that we were looking at in OnShape. You can see how that plays and how that looks from a more photorealistic standpoint. You can see those batteries. That's the real color of the batteries. You've got the plug with materials assigned that make it look and feel like the real thing. So that's actually one of the services we offer, is the ability to make it photorealistic. And then to publish something like this, you can see this is included in just a normal web page. This is a web viewer that's embedded in the web page, similar with a few lines of code, similar how you'd embed like a YouTube video or something into your website. And the cool thing here is you can add all sorts of annotations or information to augment the model. So here we can talk about this internal thermometer that's on the inside for safety. We can talk about the inputs and outputs that are integrated into the unit, the different ports, things about the battery life and what it's for, how many amps it has, etc. So again, from a publishing perspective, it's something that ONU offers as well, the ability to subscribe and publish your products out to these endpoints like web, mobile, AR, and VR. So that's really what we've got to show at this point. Again, something you could try out within your organization and see how it goes, and what kind of outputs you can get out of it based on your product.
Thanks, Sam. That was a great overview. So it looks like we have a few questions from the attendees here, and if you don't mind, we'll walk through those quickly and see if we can get you some more information. So first one is, as an engineer, I'm trying to figure out exactly how this has value to my company. I hear people talking about wanting to show our products in augmented and virtual reality, but how does this help?
That's a great question. And, you know, when it comes to augmented and virtual reality, we talk to a lot of engineers that are regularly asked from their marketing department or other people within the organization for the CAD. And I think at the time they're asked for it, they may not know what the end goal is, or they might have context around it, but I can tell you that in probably almost all of those cases, the end use is either going to be some sort of visual that's going to come out of it, whether it be, we'll call it a traditional static or non-interactive visual, which would be like a baked 3D render, or an animated video that's not interactive. That's traditionally what's come out of it. More recently, you're probably looking at something for a website like I'm showing you here, or very recently, augmented or virtual reality. And in this case, as we mentioned, for interactive real-time rendering on any of those endpoints, you really need something somewhat lightweight because of the nature of real-time rendering and the fact that you're actually interacting with it, zooming in, zooming out, spinning around. To get that frame rate that you need, you really need something lightweight. So what we provide here is perfect for handoff to those organizations, because it's going to be the lightest weight starting point you can have while keeping that great visual quality.
Great, Sam. Thank you. Next question we have is, the MyCharge example is really interactive and photorealistic. I can see it being used for trade shows, design reviews, advertising. How do you get from the app output in FBX to something like that? Is it easy? Does it take a lot of time? What tools do I need?
So, you know, I guess the first answer is it's easier when you start with the lightweight, because as I mentioned, if you do not, you're going to end up remodeling or retopologizing a lot of it, and in that case, it's going to be costly and time consuming. What we're trying to do is enable the quickest way possible to get there. So generally what would happen once you take it out and export that FBX is it would be sent out for 3D modeling, photorealism, and possibly animation. ONU does that as a service, but there are plenty of companies out there that do it as well. They'll take it into a product like a 3ds Max or a Maya or a Modo, and they'll add materials and shaders and lighting, etc., and then animate the parts that need to be animated. And from there, once you've got that, I will call it fully visualized version, then it can be taken out for publishing to any of those endpoints. And there are plenty of companies that, you know, create great AR and VR solutions. We have partners that do that as well, and we specifically have our, as Chris mentioned back in the presentation, we call our best-in-class web GL viewer, and with a subscription to our platform, you can publish out really easily to include on your website. For instance, with MyCharge, they've included on their website. They've used it for mobile sales and big sales calls, and they also used it on a big screen at a trade show at CES in 2016 and 17 with a touch screen. So as you can see, you know, the multiple endpoints really become almost endless once you've got it ready to go.
That's great. So this next one's a good question. I can see this being useful for my organization. We're happy to hear that. What happens once I use up my 3 exports? And we should revisit that. You'll recall that the app provides 3 free exports. So what happens next?
So at that point, you could sign up for one of our paid subscription plans to enable additional exports. To be honest, we're just finalizing pricing on that. We've been commercializing that, I guess, do-it-yourself sign-up subscription for a few months now, and we hope to have that done by end of October. At that point, we'll have firm pricing, but if someone runs up against that limit in the meantime, by all means, contact us and we'll hook you up with additional or talk about what pricing is going to look like as we know.
Great. Next question. Well, first, getting getting CAD to AR and VR is no trivial task, so this is exciting, indeed. And do you have any guidelines for how heavy or complex a model can be for those technologies or platforms?
The answer is it kind of depends. Rule of thumb on augmented reality, that's probably the one that's most set, is, like you're looking at a HoloLens, 100 to 150,000 polygons is generally the high end to perform. Virtual reality can be higher because generally the hardware it's running on is going to be a little more robust. It somewhat depends on the number of visuals you have in, would say, as an experience or a scene. If you've got people running around everywhere and stuff happening, the per model, it's going to be a little less. But if you're just looking to visualize one or two products, it can be, probably in the few hundred thousand. Same with WebGL. If you're looking at like this one here with the MyCharge that I'm, in this web browser, you can get away with stuff from anywhere from 100K to 500K safely. And, the good news there is, I think as you saw in our example, we were down under 25,000 starts. So, you add a little overhead when you add, photorealism and animation. But for the most part, most of our stuff comes out pretty ready for real time. I think we've had some great examples of, where we've taken it from, I'd say millions of polygons down to, a few 100,000. We often get 10 times reduction right out of the box.
Very good. So this last question we have from the audience is a good one to end on. What are your plans for additional features down the road?
When we launch the full version here at the end of October, as I mentioned, we're going to have a full suite of second pass optimization features available. What I mean by that is the ability for the user of our product to easily identify parts in a number of different ways within our application, and then either part by part or mesh by mesh, if you will, raise and lower the resolution based on how, important that part may be to your visual endpoint. Also the ability to defeature, meaning hide parts that may not be useful to what the user's trying to, or what you're trying to, express to whoever your end consumer is. And that includes the ability to identify all parts that may not be visible to the inside of a product, for example. If that's not going to be shown as part of your experience, we can identify those automatically and then, let you hide and show those. So other things planned for the future, I think say that's probably the most exciting thing that's coming up down the road.
That's great. Well, thank you, Sam. I think that's all the questions I can see from the audience here. So thank you, Sam, and thank you, everybody, for joining us today. For more information about the company, you can go to our website, www.onu1.com, and feel free to reach out if you have questions. And we hope you enjoy the app. Thank you.
Thanks.